This is second part of video for the worked solution 2026 physics paper. Let's get into question 24. A spaceship is approaching the planet. They compare with the attractive force and a distance as measures to the center of the planet. So that is actually the gravitational force of the attractive force, right? So let's say our gravitational force F equal, and we have to compare the force and the distance between the center of the mass. However, if you see the x-axis, we have d here, but in that case, we have d squared here, and we have d negative 1 and d negative 2. Okay, so let's think about what's the gravitational force equation. That's G mass m over r squared. But in that case, we replace with the d squared, right? So if you see that, and we notice that the force and the distance squares um, relationship, that's F is proportional to 1 over d squared, right? So 1 over d squared is essentially d to the negative 2, which is d in that case. Moving to the question 25, we have satellite orbiting the Earth, and Earth is at the center, and the satellite is orbiting around the Earth. But we have the two orbits here, right? And higher orbit and lower orbit, they said the situation is from higher orbit to the lower orbit. And if you think about it, the only changes they made is the distance between them gets closer, which means that the distance decreases, right? So d decreases. And they talk about the speed and orbital period. So if you think about the speed, so they can either talk about like the orbital speed or the linear speed. Okay, the two different things. But let's think about the orbital speed first. If you think about the orbital speed, it's given in a formula booklet. So that equals to root gm over r. And the orbital period, we have exact formula to calculate that one. But the thing is, we have to derive them. But if you think about the Kepler's third law, we can say the period square is proportional to the distance, in that case, r cubed, right? So let's think about the distance decreases. Okay, so when the distance decreases, in that case, so r decreases, right? That means the whole equation, which is orbital speed, increases. Okay, so gonna go with increase in speed. And how about period? So distance r now decreases, right? If you think about the r decreases, the whole value decreases, which means that the whole value of t squared decreases, which means that period t decreases, okay? So t decreases, which means that the orbital period gets shorter, which means that answer is A. Okay, next question, question 26. Their escape speed from the surface is E Earth. So let's just assume that that's V equals to, because that's escape speed, the formula is given in the formula booklet, which is 2gm over r, right? And then they said, what is the escape speed from the surface of the planet that has mass 6 times that of the Earth? Okay, so let's say another planet P, the mass of P is 6 times of mass of the Earth, and the volumes are 27 times that of the Earth. Okay, so the volume of the planet is 27 times of the volume of the Earth. So when we think about the volume, we should think about the volume as 4 over 3 pi r cubed, right? So volume is actually directly connected with the distance r. So if that case, we can say the v, we can always swap that as the r, right? So I go with, instead of vp, so that's 4 over 3 rv rp cubed equal 27 times 4 over 3 pi r earth cubed. Then these two cancels out, so we don't have to care about. So let's just like put it into the formula here, and let's assume that v is just about the Earth. Okay, so I just put it the Earth, mass of the Earth, and the radius of the Earth. So that's the v of the Earth. And how about the other one, the planet one? So we're gonna put into the planet, v of the planet equal root 2g times m. Instead of mass of the Earth, we're going to put into the mp, right? But that mp is same as 6me, so that's going to go with 6me and divided by. So we have radius of the p, but instead of the radius of the p, we're going to go with that one, but you always have to do with this in order to put that into the formula. So if you think about 27, that's 3 to the power of 3, and that's r e to the power of 3 of 1/3. So that is just 3 times re cube, re. So without cube, right? So that's 3re here. So when I have these two equations with separate things, then I'm just gonna divide into the two parts, the upper part and the lower part. Okay. So this divided this equals to that divided that. So 2 of g cancels out, and me cancels out, re cancels out. Okay. So the one left with is 3 divided by 6, which is 2. So the whole thing's upper side cancels out, and the bottom side we only have root 2, right? So ve over vp equal 1 over root 2. That means that vp is root 2 vp. So root 2 is about 1.4, so the C must be the answer. Okay, next question. We have question 27. We have two positive charges, and we have to see what's going on with the electric field between them. And if you think about, we have Q and 3Q. Of course, 3Q is greater than the Q, which means that they should have more line, the field line, than the Q, right? So that means that the A and C automatically cancels out because they have the same line of the Q and 3Q. That's impossible, right? How about B and D? Okay, so they have more line, the field line with the 3Qs, but only difference is between D and B is in B, they're like the middle line is just at the middle between, at the center between Q and 3Q, but in D, it's more like the DQ side when they have these asymptotes, right? Which one do you think is correct? Obviously, it's not going to be at the center between Q and 3Q because that one is greater than this one, right? So that one has more power, so it has to push to the Q side, which is D in that case. It's a pretty easy one. Okay, question 28. We have a point charges, and there has reason around the isolated point charges. Not sure like what does the black circle represent, but they said in which diagram does the reasons shows the equipotential line. So equipotential line. If you think about equipotential line is the line that represents the potential is the same. Okay, if you think about the potential V is equal negative Gm over R. So if that is equipotential line, the R, the distance between one point to another must be the same. That means that the line, it's the radius is the same, it's just a circle, right? But the thing is, it has to be a perfect circle. It cannot be something like this. It shouldn't be the elliptical orbit, okay? There must be like positive charge, like this one is perfect circle. I think that's fine. That's not fine. This is fine, okay? Because that's perfect circle. Right, so except 2, we have 1 and 3 are correct, so it should be B. Next question, question 29, is a particle passing through a two parallel plates, which they have the uniform electric field inside, right? So they said it's negative charge, so let's put the minus sign in here. If you think about it, we have two forces they can interact, which is firstly weight, right? So weight must be downward here, which is just mg. So let's think about the electric force in that case. So that's positive here and negative here, and the charge is negative, right? So it has to be the negative pushing up, the attractive force acting between plus and minus, so it goes up, right? So their attractive force has to be going up. Right. From that, actually, we can say the what's the resultant force is just a B, right? However, let's think about how the electric force we can get is if you think about the field strength E. So E is the force divided by charge Q. So our electric force F equals to E times Q. So that's why that is EQ. So that's EQ minus mg, right? So EQ minus mg must be B. Okay, let's get into the question 30. We have a magnet going into a coil. So it seems like a induction questions, right? And in fact, it is the induction questions. And the conditions they are given is the ton of coil is 100, and the speed it goes into the coil is 2 meters per second, and the induced EMF is 400 volts, right? And we have the second conditions, which we have number of tons equals to 300, and the EMF induced is 300 volts, and they want to know what's the new speed for that, okay? And for that induction questions, they normally ask the EMF, right? The induced EMF, we have something called Faraday's law. So that Faraday's law is most fundamental things we have to use all the time. However, this one is like too general, right? You can use either like any situation actually. You can use either like when the coil's turning, like rotating, or when the coils goes to the linear, right? So in any situation, we can use the Faraday's equation. However, when the coil goes to linearly, then we can use another equation that's from the Faraday's equation, but in a simple version, okay? So EMF equals to B VL. You can find in formula booklet. You can find formula booklet with these two equations, but I teach students normally in any situation you can use the Faraday's law. However, in IB, they mostly use in rotating situation, okay? When the coil is rotating around. So in that case, you can use Faraday's law. But there's another case when the coil is moving linearly, right? It goes like linear line with the velocity, then you use that equation. It's much simpler, right? So in general, you can use that one. But in this, like these questions, when the coil moves linearly, then you use this equation. It's much easier, okay? So if I try to use that equation, for the first one, we have EMF equals to BVL. But there's things that you must be aware of, because that one only care of when the number of turn equals to 1. Okay, they normally gives a situation that there's no number of turns or number of turn equals 1, or like a linear piece of line goes linearly. Okay, which means the number of turn is just equals to 0, so equals 1, right? But that is like very simple situation. We're not going to deal with any like that simple situation in IB question, in fact. Like for example, in that question, we have 100 tons and 300 tons, right? In that case, we have to actually times number of tons n here, right? So I always teach students that this equation is pretty easy, but when you have number of tons, you always have to multiply it with n, okay? So we actually have to multiply with the n. So let's put into the number in the first, using the first one, which is in that case, 400 equal, we don't know B and we don't know L, so let's BL, something that we don't know. And V is 2, and number of ton is 100, right? Okay, not going to calculate right now. I'm just going to put in the new equation here, new conditions here into the equation. Okay, so EMF, we have 300 here. That equals to, we still don't know B, and we still don't know the length L, but we only know the length is the same, and also the B is the same because we're going to use the same magnets, right? So BL is the same. Times speed, something we don't know, and number of tons, we have 300 here. So we have these two equations. We can either just like calculate what's BL and just substitute BL, or you can just like divide upper part and lower part. But in that case, I think calculating BL is much easier. So using that one, this 2 is 200, right? 200 divided by 400 divided by 200 is just a 2. And we substitute 2 here. And 300 cancels out. So we can say that 1 equals 2 times V. So therefore, V equals just half, which is the okay. Next, we have question 31. And we got the situations right. It also implies the EMF things in here, or like at least D.4 EM inductions thing. So what's the conditions they are given? They said the radius of the ring is 5 centimeter. So I don't like the 5 centimeters, so I'm going to change into the meters. And they said the uniform magnetic field B is 0.5 Tesla. And the angle of rotation measured from the horizontal, they just want to know what's the angle, right? So what's the angle? And the last thing, the magnetic flux through the ring is 2.0 microweber, right? So magnetic flux is pi equals to 2.0 times 10 to the negative 3 Weber. So we have these equations are given, but using that equation, using that conditions, what equation can you think of? For me, I can think of pi equals to BA cosine theta, okay? So we have 2 times 10 to the negative 3 here equal B, we have 0.5, and A, in that case, we have to think one more step because that's the circle, right? So we have to calculate the area of this, which is pi r squared, pi times r. We have 5 times 10 to the negative 2, that's squared, times cosine theta. So we have all the numbers and we have theta here, then we can actually calculate using the calculator. then you have about like 59 point something something degree. So that goes to 60 degree. Next, we have question 32. It looks like the energy, which is 8.1, is the energy level part, right? So they said which statement gives the correct wavelength for the transition from n equals 4 to n equals 2. So from here to here. So if you think about it, obviously we're going to use delta E, change in energy level, equals to h times f, okay, the frequency, right? So what's change in energy? It's from minus 3.9 to minus 8.7. So that means that we have from this minus 3.9. That's the change in energy, right? So it gives us negative 8.7 plus 3.9 as the change in energy. We can say just actually because that should be the positive, then it actually should be like the modulus sign, the absolute value for that, right? That actually gives us 8.7 minus 3.9 EV. That's change in energy. How about like the other part here? That's equals to h times f. We want to know the wavelength bit, right? So using the speed of wave equal frequency times wavelength, and we know that that speed should be the speed of light. So c equal frequency times lambda. That means that lambda equal c over frequency f. So let's substitute. Sorry, again. So that f equals, we can say c over lambda. Then let's substitute that's hc over lambda here, right? So if you want to calculate the lambda, lambda goes to that way, and this whole value goes to that way. That means that we can have lambda is equals to, we have hc over 8.7 minus 3.9 EV, which is in that case should be C, right? Next question, we have the radius of the gold. Sorry for the fuzzy bit here because of like, the words equation is not like very perfect for that. But anyway, you can recognize what it is. So we have the radius of the gold, and we have the R0 part in here. Then the equation that we have to use is pretty obvious, which is R equals to R0 A to the power of 1/3, right? So A is the mass number, which is this part here. Right. So the R equal now R0 and 197 the power of 1/3. So which means that's just C, right? So that's pretty easy. You can actually solve that question in like 20 seconds or 10 seconds even, right? Next, we got question 36. And question 36, we have the graph here, and they talking about the half-life here. So we just have to read what's the half-life here, right? So the half-life part is when the 1,000 goes to 500, right? And we gotta read what's the time for the 500. So from here, we got here. So that part we have 1,200 seconds, right? The seconds goes to the minute, and we have to divide it by 60 seconds for the minutes. Then that should be 20 minutes, right? So A should be correct one. However, there's a warning that some of this type of question has to be careful, okay? Because sometimes they actually give us some information about the background radiation here. So like what kind of clue that if that is include the background radiation, background things in here is that, for example, if the graph line looks like something like this, let's say, it goes to there, and then the tail part is just like goes to straight about here. Okay, let's assume that we have these kind of things, okay? Then we have to take account the background radiation part in here, okay? So in that case, for example, the background radiation should be 200. Then if that case, then we have to subtract 1,000 minus 200, which is 800 is our initial value. And then we just divide it by 2 and 400. Then we have to read 400 lines for the half-life, okay? But in that case, it is not the case about the background radiation, so we're going to just move on to the next one, but sometime it is. Okay, next we have question 37. So which is correct statement about the nuclear power plant? So, okay, let's read it out. So fission process generates radioactive waste that is difficult to dispose of it. That's actually a correct one, right? Okay. How about question B? The nuclear power plant uses water from nearby rivers But actually, not reverse, should be the C. But anyway, to control the chain reaction, of course, it cannot control the chain reaction. Okay, the only use of the water is just to cool down, right? So this one is also incorrect for that. So that's not it. See, nuclear power plant use the control rod to cool down. No, the control rod is to control the fission rate of the chain reactions, right? How about D? The chain reaction in fission reactions are unstoppable once they have started. No, we we control with the control rod, right? So this is not correct. So A must be the answer. Next, we have question 38. They're talking about nuclear fusion, which is the opposite things with the previous questions. They said, why are these stars not exploding? Okay, so you have to think about like why they are not like exploding outwards, because they have something holding inward, right? So we have to think about something like grabbing inward. If you read it out A to D, then we have the D, which is the gravitational inward force are equilibrium with the outward pressure. That's correct, right? So we have outward radiation pressure, something cool, right? Question 39, we have the HR diagram here, and they ask in this HR diagram, where the sun begins and ends with this process, right? So the sun goes from the main sequence, right? And the sun should be in this part here, like in this line, right? Because that y-axis measures the luminosity compared to the sun, and sun's luminosity divided by sun's luminosity must be 1. So like this one line should have like this one here, and sun should be around here, which is like around the Q, right? So it starts from the Q, and after they finish the main sequence, finishing the main sequence means that they run out of their fuel as hydrogen, right? So it goes from the red giants here, this part. However, so the red giant part is when the gas expand a lot. Okay, when the gas expand a lot and they use the fuel as the different elements, for example, hydrogen, and the next one is helium. Next one is something else, something else, something else, right? So after the red giant, it goes to like this part here. In IB, they don't really teach what's the that part here, but it is called the planetary nebula. Okay, all the gases are expanding. So when you see like the galaxy picture, and we have all like beautiful gas, like colorful gas, that's all have this planetary nebula process. And then after that, actually, it goes to that way to die. So this part is something called the white dwarf, right? So actually, the sun must end with the white dwarf, but they don't have it in the questions, right? So we actually should have said that it should be S. But in fact, it actually should go that way here. Finally, we got the last question, question 40. We have a very distant star is measured to have the parallax angle, which is zero point 0.1 arc second. So what is distance to star in SI units? Right. In SI units, the parsec is not an SI unit. Light year is not an SI unit, right? So we have two possibilities, so C and D, right? But if you think about how to calculate the distance to star, we have the parallax angle. So distance is equals to 1 over parallax angle, which is 1. But in that case, that's 1 parsec, right? To calculate the 1 parsec, we have to use the 1 parsec is equals to 3.26 light year. And 1 light year represents 9.46 times 10 to the 15th meter. You can find in the formula booklet, right? You don't have to memorize anything about it. Then if you calculate that one, it should be about 3.1 times 10 to the 17 meters, which in that case, the C must be the answer. Right. This is the end of the video. And I believe question 34 and 35 are missing. The reason why they're missing is because they don't have it in the leaked version or the donated version in 2026 past paper. Okay. Thank you for watching the video. I'll do the next part, which is paper 1B and paper 2 in sequence. And comment if you have any questions. Thank you.